Hello everyone, good evening. I think I'm audible, right? I'm audible? I think I'm audible, right? Yes, thank you, thank you. Yes, this is lecture number 25 of ODE. So if you haven't watched all the previous videos, so please watch all the previous videos and come back to this video, right? So we are going to complete ODE in another 3 more videos, right? So in this class, we'll be solving application of Laplace transform for solving a differential equations. In this class and next class, we will be solving this topic. After that, we will be taking a topic called orthogonal trajectories. That is the final topic in ODE, right? Yes. So everything is perfect, right? So from here onwards, the classes will be on interactive panel. Um, yes. Okay. So we'll start. So before getting into this, we need to know basic. We need to have a basic understanding about Laplace transform, right? Uh, in our YouTube channel, we have already published a video, right? We have already published a video of Laplace transform, right? You just go to YouTube and just type Laplace transform math press. You will get this one shot video. You can see it is of almost 7 hours video. So if you have seen this video, you know a basic concept about Laplace transform, right? You know all the formulas. You know all the formulas based on Laplace transform, right? Yes. So I'm assuming that you have watched this video already before getting into today's class, right? Yes. Super. These are the basic formulas of Laplace transform. If you have seen that video, if you have seen that 7 hours video, this is the formula we have already discussed in that video, right? I have also given the proof of all these formulas. So you can see Laplace transform of 1 is 1 by s. Laplace transform of e power at is 1 by s minus a. Laplace transform of t power n is n factorial by s power n plus 1. Laplace transform of sin at is a by s square plus a square. And Laplace transform of cos at is s by s square plus a square. And these are the formulas we have already discussed, right? So don't think all are new. We have already completed all those in the previous days itself, right? So you just go to YouTube and just type Laplace transform math press. You will get this one shot video. If you have seen this video, this is a very easiest topic, right? Yes. So what we're going to do is we're going to apply the formulas or concept of Laplace transform in solving a differential equations, right? In solving a differential equations. um okay, okay, everything is fine, so we'll start, right? Okay, so before getting into this, you just, these are the very important note, right? That is L of y dash. So y dash is dy by dx or dy by dt, right? Yes. So you can see L of y dash is s into L of y minus y of 0. So these are the very important 4 notes you need to understand before getting into today's topic, right? This Laplace transform of y dash. Y dash is dy by dx or dy by dt, right? Your dependent variable can be anything, right? So L of y dash is s into L of y minus y of 0. L of y double dash is s square L of y minus s into y of 0 minus y dash of 0. So you can see it will start with s square, s constant. First term will always be L of y, y of 0, y dash of 0, right? You can see L of y triple dash. So s cube, s square, s constant. So our first term will always be L of y, y of 0, y dash of 0, y double dash of 0. And what about L of d power 4, y by dx power 4? That is fourth derivative. S power 4 L of y, s power 4, s cube, s square, s constant. First term will always be L of y, y of 0, y dash of 0, y double dash of 0, y triple dash of 0. You can see a pattern, right? So in that way, you can continue on and on. But you just remember these 4 important notes which will be helpful in solving the problems, right? So I'll be moving out of the board just to see the comment section. Um, yes, Fazil Rahman. Okay. Don't think that I'm moving out of the board. So I'm moving out of the board means I'm seeing the comment section, right? Okay. Yes. So we'll start the first problem, right? And you also have you should also have the basic knowledge about how to do partial fraction, right? So there are three types of partial fraction, right? If your denominator has distinct root means you will have one partial fraction. If your denominator has repeated root means you will have one partial fraction. If your denominator has complex roots means you will have one format of partial fraction. There are three types of partial fraction which we have already discussed in many videos, right? So you also you have to so before getting into today's topic you have to recall partial fractions and Laplace transform. That's it. If you know these two topics, this topic is very easy, and there is 60 to 70% there is one question in this topic in UPSC point of view, right? Okay. So in this class we're going to do 5 problems. This class we're going to do discuss 5 problems, and in the next class we will continue from 6th problem, right? Okay, so we'll start. So solve d square y by dt square plus 5 dy by dt plus 6y is equal to 2. See, you can easily solve this by that second order differential equation, the constant coefficients, right? You can easily solve that by using characteristic function and particular integral. But we are going to apply Laplace transform here. See, you can do the same problem which we already did in the previous cases, where we will be solving this a differential equation of second order with a constant coefficient, and you can see RHS is 2, that is 2 into e power 0x, so it comes under type 1. You can easily solve in that also, but here we are going to apply Laplace transform. In the exam point of view, if they give solve means you can solve by any method, but if they say apply Laplace transform to solve this means you need to solve by Laplace transform method, right? Okay, so what you can do is I'm going to do by Laplace transform. So without Laplace transform, you take this exercise. You already know how to solve this problem without using Laplace transform, right? So find the auxiliary equation, find characteristic function, depending upon the nature of roots, find particular integral. General solution is y is equal to cf plus pi, which you already know, right? Yes, you can also do that method, but here we're going to do all those problems by Laplace transform method, right? Yes. So we'll do. So you can see we have these. We need to find a function y, right? We need to find a function y such that we have differentiate that y twice, 5 times differentiate that function once, 6 times y after give me 2. You need to find that function y. These two are initial condition. It is given to find the value of the arbitrary constants, right? Okay. So we'll start solution. So you can see it is y double dash, right? So y double dash plus 5y plus 6y is equal to 2, right? Now you take Laplace transform on both sides, right? You take Laplace transform on both sides. So apply Laplace transform. So apply Laplace transform. So apply Laplace transform on both sides. So this will be L of y double dash, right? So Laplace transform satisfies linearity property. So you can directly get Laplace into each parts, right? Okay. So this will be 5 into Laplace transform of, sorry, this y dash. So L of y dash plus 6 into Laplace transform of y is equal to L of 2. Right? This satisfies linearity property. That means you can take constant outside. Right? Okay. Now what is L of y double dash? Just now I have written the note, right? So it is s square L of y minus s into y of 0 minus y dash of 0. So this is the Laplace transform of L of y double dash, right? So you can see L of y double dash is s square L of y minus s into y of 0 minus y double dash of 0 plus 5 into, now what is L of y dash? So it is s into L of y minus y of 0, right? You just keep this L of y as it is. Now we can take 2 outside. So if we take 2 outside, it will be L of 1. So L of 1 is 1 by s, right? Laplace transform of 1 is 1 by s. These are very elementary formula which you already discussed, right? So L of 1 is 1 by s. So just go through that Laplace transform video. It will be very, very easy for you, right? Yes. Okay. Now what we can do is you need to apply initial condition, right? So initial condition is y of 0 is 0, y dash of 0 is also 0. So that means y of 0 is 0, y dash of 0 is also 0. Or this problem, right? If there is some number means you have to put that number here. So since y of 0 is 0, y dash of 0 is 0, these two will be 0 and this will also be 0. right? So what I'm doing is using y of 0 is 0 and y dash of 0 is also 0, right? I'm using these two conditions. So that means we will be left with we will be left with s square L of y plus 5 s into L of y plus 6 into L of y is equal to 2 by s, right? Now if we take L of y outside, so if we take L of y outside, we will have s square plus 5s plus 6 is equal to 2 by s. So this means L of y is equal to 2 divided by s into s square plus 5s plus 6, right? So apply partial, factorize this, right? Factorize s square plus 5x plus 6. It will be s plus 2, s plus 3, right? So 2 divided by s into s plus 2, s plus 3, right? You just apply, factorize this quadratic equation. So it will be s plus 2, s plus 3. That means we have L of y. So we have L of y is equal to, so we have L of y. So we have L of y is equal to, so 2 divided by s into s plus 2 s plus 3, right? 2 divided by s into s plus 2 s plus 3. That means we need to find y, right? Y is our solution. Yes or no? You can see y is our solution. So in order to find y, we need to apply inverse Laplace transform for this function, right? That means, so in order to find y, so y is nothing but L inverse of this function, right? Take this L to that side, take this L to that side. So it will be 2 divided by s into s plus 2 s plus 3, right? 2 divided by s into s plus 2 s plus 3. So this is our required f of t. This is our required solution. But we need to find inverse Laplace transform for this function, right? How to do? Very simple, right? So you just take this as star, right? You just take this as star. So first what to do is you need to apply partial fraction for this f of t, right? You need to apply partial fraction for this f of t. So we have 2 divided by s into s plus 2 s plus 3. So this is nothing but, so you can see these are distinct roots, right? So we have three distinct roots, 0, minus 2 and minus 3. So it will be a by s plus b by s plus 2 plus c by s plus 3. Right? You need to find the value of ABC now. These are very simple, right? So that is, you just multiply by s into s plus 2 s plus 3. So we have s is equal to a into s plus 2 s plus 3 plus b into s into s plus 3 plus c s into s plus 2, right? I'm just applying partial fraction. I'm just multiplying throughout by s into s plus 2 s plus 3 throughout. So this s into s plus 2 s plus 3 will get cancelled. So this one s and one s will get cancelled. So we'll have s plus 2 s plus 3. These are very elementary, right? These are very, very elementary. Okay. So you need to find the value of ABC now. So what are the t distinct roots? 0, minus 2 and minus 3, right? Just apply the value of those. So put s is equal to 0. So put s is equal to 0. So if s is 0, we have, sorry, this is 2. Right? So put s is equal to 0. So we have 0 is equal to, so this will be a into 2 into 3. And this b will be 0, c will be 0, right? Because 0 into something is 0, 0 into something is 0. So that means the value of um, this 2, this means this 2 will get cancelled. So we have a is equal to 1 by 3, right? I'm just substituting s is equal to 0. So we have 0, 0. So 2 into 3, this is 2, right? Now put s is equal to minus 2. Now put s is equal to minus 2. So s is minus 2, we have 2 is equal to, this a will be 0 because minus 2 plus 2 is 0. B will be minus 2 into minus 2 plus 3. C will again be 0 because minus 2 plus 2 is 0. So this 2 will get cancelled. So we have 3 minus 2 is 1. So we have um, so we have b b is equal to minus 1, right? So we have 1 is equal to minus b. That means b is minus 1, right? So a s is 0 means a is 1 by 3. Um, yes, b is minus 1. Now similarly, you just apply, put s is equal to minus 3, right? So if s is minus 3, we have 2 is equal to a will be 0, b will be 0. So if I put minus 3 here, we have c into minus 3 minus 3 plus 2. So that means we will have c to be equal to, so we have 2 is equal to, so this will be minus 1. So minus minus will be plus, so we'll have 3c. This means the value of c is 2 by 3, right? The value of c is 2 by 3. So we have found the value of ABC now. Just apply that in a partial fraction, you will get the answer, right? Yes. So we have, yes. So we have so 2 divided by 2 divided by s into s plus 2 s plus 3 is equal to a by s plus c by s plus 2 c by s plus 3, right? So what is the value of a? The value of a is 1 by 3, right? So this will be 1 by 3 into 1 by s. Value of b is minus 1, right? So I can write this as minus 1 by s plus 2. And what is the value of c? C is plus 2 by 3. It will be 2 by 3 c by, sorry, the value of c is 2 by 3. So we will have 1 by s plus 3, right? So if I apply L inverse on both sides, I will get the required solution y of t, right? If I apply L inverse on both sides, I will get the required y, because y is L inverse of this function. So if I take L inverse on both sides, L inverse of this is the required answer, right? Okay. So this implies L inverse of 2 divided by s into s plus 2 s plus 3 is equal to, so this is 1 by 3 L inverse of 1 by s minus L inverse of 1 by s plus 2 plus 2 by 3 L inverse of 1 by s plus 3, right? Now you have to thorough with all the formulas, right? So what is L of 1? So we know these three formulas, right? So we know L of 1 is 1 by s, right? L of 1 is 1 by s. That means 1 is equal to L inverse of 1 by s, right? So L inverse of 1 by s is 1. You need to apply inverse. And similarly, we know L of e power at is 1 by s minus a, right? L of e power at is 1 by s minus a. That means e power at is equal to L inverse of 1 by s minus a, right? Just compare these two. So L inverse of 1 by s is 1. So this will be 1 by 3, right? This is 1. So 1 into 1 by 3 is 1. And this will be L inverse of 1 by s plus 2. Okay, so you need to apply, what is the formula for e power minus at? L of e power minus at will be 1 by s plus a. So this implies e power minus at is equal to L inverse of 1 by s plus a, right? I have also listed out all the formulas this slide, right? So you can see L of e power at is 1 by s minus a. L of e power minus at is 1 by s plus a. So you just go through that Laplace transform video, you will have more clarity. So that means if I make use of these formulas, so this is e power minus 2t, right? Because you can see when a is 2, L inverse of 1 by s plus 2 is e power minus 2t plus 2 by 3. This is what? E power minus 3t. That's it. This is your required answer. right? Therefore, this is your y of t, right? You can see L inverse of this is equal. This is your required y of t. So therefore, the solution is y of t is equal to 1 by 3 minus e power minus 2t plus 2 by 3 e power minus 3t. See, you can also do the same problem using the characteristic function particular integral. You'll be getting the same answer. Have anyone done that? Okay, so we'll move on to the second problem. Is there any doubt? Is there any doubt in this problem? See, very simple, right? So this is y double dash. Here different variable is t, right? So d square by dt square plus 5 divided by dt plus 6y is equal to 2. So y double dash y dash y. Take L on both sides. Make use of the node. You bring L of y to one side, right? You bring L of y to one side, and after that you have to apply L inverse to this function. So do partial fraction for this and then do the problem. Very, very simple. Okay. We'll move on to second problem. No doubt, right? Is there any doubt? Okay, no doubt. So solve d square by dt square plus 6 dy by dt plus 8y is equal to 2, given that y of 0 is 1 and y dash of 0 is 1, right? We'll do the same problem again. Here you can see the initial conditions are different, right? Y of 0 is 1, y dash of 0 is again 1. Okay, so we'll move on to the problem. So this is nothing but y double dash plus 6y dash plus 8y is equal to 2, right? So apply Laplace transform on both sides. So take Laplace transform. So take Laplace transform on both sides. So take Laplace transform on both sides. So this will be L of y double dash plus 6 into L of y dash plus 8 into L of y is equal to L of 2, right? Is equal to L of 2. Again same process. So we know L of y double dash, L of y dash, L of y, just apply. So what is L of y double dash? So it is s square L of y minus s into y of 0 minus y dash of 0 and 6 into L of y dash. So what is 6? 6 into L of y dash. So it will be s into L of y minus y of 0 plus 8 times L of y. Now again L of 2. I can take 2 outside. So 2 into L of 1. So L of 1 is 1 by s. So we will have 2 by s. Right? Now you need to apply initial conditions. So it is given that y of 0 is also 1, y dash of 0 is also 1. So we will have s square L of y minus s minus 1, right? Because y dash of 0 and y of 0 both are 1. So minus s minus 1 plus 6 into 6s L of y, and again this value is 1, so it will be minus 6 plus 8 into L of y is equal to 2 by s, right? Now take L of y common here. So if we take L of y common, this will be s square plus 6s plus 8, right? S square plus 6s plus 8, and this will be minus s minus 1 minus 6 is equal to 2 by s, right? Minus s minus 1 is equal to 2 by s. Okay, both are 1. Okay, so this will be now you take all these terms to that side, right? All these terms to that side. You should always have L of y into something is equal to something, right? Okay, so if we take these two terms to that side, so we will have L of y s square plus 6s plus 8 is equal to 2 by s. So it will be minus 6 minus 7. Sorry, minus s minus 7. So it will be plus s plus 7, right? Plus s plus 7. Okay. Now cross multiply this. So we will have s square plus 7s plus 2 whole divided by s, right? S square plus 7s plus 2 whole divided by s. Okay, now you need to bring this term to this denominator. So we will have L of y is equal to, so we will have L of y is equal to s square plus 7s plus 2, sorry, s square plus 7s plus 2 divided by s into s square plus 6 s plus 8, right? Okay. Now, I think we can factorize this, right? Sum is 6, product is 8. Sum is 6, product is 8. 4 twos are, sum is 6, product is 8. Yes, right? 4 plus 2 is 6, 4 to 2 is 8. That means that is s minus s plus 4, s plus 2. Right? So this means this will be s square plus 7s plus 2 divided by s into s plus 4 s plus 2, right? I'm just factorizing this. That's it, right? These are weights and 11. S square plus 6s plus 8 can be written as s plus 4 s plus 2. That means in order to find y, so y is nothing but L inverse of s square plus 7s plus 2 divided by s into s plus 4 s plus 2, right? So this is our required function y of t, but we need to find this inverse Laplace transform for this function. You have to do partial fraction. After that, you need to apply L inverse, right? No doubt, right? Okay. Now we will take this function and then we will do partial fraction. So we have s square plus 7s plus 2 divided by s into s plus 4 s plus 2. So this is a by s. You can see all are distinct roots. So a by s, b by s plus 4, c by s plus 2, right? So multiply throughout by s square plus 7s plus 2. Sorry, multiply throughout by s into s plus 4 s plus 2, right? Multiply throughout by s into s plus 4 s plus 2. So we will have s square s plus 2 is equal to a into, so if I multiply throughout by s into s plus 4 s plus 2, so this term will get cancelled. So we will have s plus 4 s plus 2. See, I'm just doing this naturally because these are very simple, right? I'm not explaining this because you are very high level. So you know how to apply partial fraction, right? I'm not doing step by step. Okay. I'm assuming that you know how to do partial fraction. These are just 11th standard level mathematics. Okay. So s plus 4, so it will be s into s plus 2, and this will be s plus 2, right? S into s plus 4, s into s plus 4. So now we need to find the value of ABC. So put s is equal to 0, right? There are three distinct roots, 0, minus 2 and minus 4. So plug all those values here. So if s is 0, so we will have 0 plus 0 plus 2. So 2 is equal to a into 4. Here we will have 2. 0 plus 4, 0 plus 2. These two terms will be 0 because 0 into 0 into when s is 0. So these two will get cancelled. So we have a is equal to 1 by 4, right? Now you put s is equal to minus 2. So if s is minus 2, you can, this will be 4. Minus 2 square is 4. This will be minus 14. 7 into minus 2, right? Minus 14 plus 2. Now s is minus 2. A will be 0, B will be 0. So we have C minus 2. Minus 2 plus 4 is plus 2. So 4 minus 14 is minus 10. Minus 10 plus 2 is minus 8 is equal to C into minus 4. 4 will get cancelled. 4 ones are, 4 twos are. So we have 2 is equal to C. Right? We have 2 is equal to C. Okay. Value of C is 2. Now similarly, you put S is equal to, right? Put S is equal to minus 4. Now if S is minus 4, minus 4 whole square is 16. 7 into minus 4 will be minus 28. Minus 28 plus 2 is equal to, so if S is minus 4, this will be 0, this will be 0. So we have, uh, sorry, this B, right? This B. Okay. So we have when S is minus 4, so this will be B into minus 4 minus 4 plus 2, right? Minus 4 plus 2. So this will be 16 minus 28 is minus 12. Minus 12 plus 2. Minus 12 plus 2 is minus 10. So we have minus 10 is equal to b into minus 4 minus 2, right? So we have minus 10 is equal to 10b, minus 10 is equal to 8b. So 2 4s are 2 5s are, right? So we will have c to be b to be equal to minus 5 by 4, right? B to be equal to minus 5 by 4. So we have found the values of, A, B, C now, right? Now substitute back here. You will have, just a minute. Okay, so we will have s square plus 7s. So we have s square plus 7s plus 2 divided by s into s plus 4 s plus 2, right? S plus 4 s plus 2. So this is a by s plus d by s plus 4 plus c by s plus 2, right? Now we already found the values of a, b, c. Just substitute, you'll get the answer. So what is a? A is 1 by 4. So this will be 1 by 4 into 1 by s. Value of b is minus 5 by 4. So it will be minus 5 by 4, 1 by s plus 4. Value of c is 2. So this will be 2 into 1 by s plus 2, right? Now you take inverse Laplace on both sides. So apply L inverse, right? So apply L inverse on both sides. So this will be L inverse of s square plus 7s plus 2 divided by s into s plus 4 s plus 2 is equal to, so 1 by 4 L inverse of 1 by s. So 1 by 4 L inverse of 1 by s minus 5 by 4 L inverse of 1 by s plus 4 2 times L inverse of 1 by s plus 2, right? So this is 1 L inverse of 1 by, this is 1 by 4, this is 1, right? This is minus 5 by 4 e power minus 4t. So L of e power minus at is 1 by s plus a. So we will have e power minus 4t 2 times e power minus 2t, right? This is your required solution. So therefore the required y of t is, see, you can do the same problem using that characteristic function and a particular integral also. So you can also do that problem by that method also. There will be some arbitrary constants there, right? In order to find, we will be writing cf using arbitrary constant. To find the arbitrary constant values, make use of these initial conditions, right? Okay. So therefore this is our required solution. Y of t is 1 by 4 minus 5 by 4 e power minus 4t plus 2 into e power minus 2t. Right? Is there any doubt? Very easy, right? No doubt, right? Okay, so we move on to the third problem. So solve, actually this is UPSC question. So solve y double dash minus 2y dash minus 8y is equal to 0. So it is given that y of 0 is 3 and y dash of 0 is 6, right? Okay, so we'll do. So you need to solve by Laplace transform. We are doing every problem by method of Laplace transform, right? Okay. Now, solution. So take Laplace transform on both sides. So we will have L of y double dash minus 2 times L of y dash minus 8 times L of y is equal to, is 0 or what? Just a minute. Check the question. Yes, it is 0 only. Super. So that means you don't need to apply L of 0 is again 0 only, right? Let us take this as 0, right? So if you have some if you have some functions here, L of 1 is 1 by s, L of e power minus 2t is 1 by s plus 2, you can write that. Here you have 0. Okay, super. So L of y double dash. So s square L of y minus s into y of 0 minus y dash of 0. And what about L of y dash? So it is s into L of y minus y of 0. And here we have 8 times L of y is equal to 0. Right? This is a UPSC question. Right? Very simple question. So we will apply initial condition. So y of 0 is 3, y dash of 0 is 6. So we have s square L of y s into y of 0. So y of 0 is 3, y dash of 0 is 6. Right? Okay. So this will be minus 2 times s into L of y minus y of 0. So y of 0 is 3 minus 8 times L of y is equal to 0. Right? Minus 8 times L of y is equal to 0. Okay. So we have s square L of y minus 3s minus 6 2s L of y plus 6, right? Minus 2s L of y plus 6 minus 8 times L of y is equal to 0. Now just take L of y common, right? So we take L of y common. So we have s square minus 2s and here we have minus 8, right? S square minus 2s minus 8. And what are the terms that doesn't contain L of y? So we have minus 3s minus 6 plus 6 is equal to 0, right? Minus 6 plus 6 is equal to 0. I think the question is correct. Okay, okay. So these two will get cancelled. So that means we have L of y is equal to, so take this term that side. So we will have 3s divided by, bring this term to the numerator denominator. So we'll have s square minus 2s minus 8, right? So we will factorize this. So 3s divided by, so s square minus 2s minus 8. So sum is minus 2, product is minus 8, right? Sum is minus 2, product is minus 8. So this will be minus 8, sum is minus 2. So I can write this as minus 4, 2, right? Minus 4 into 2 is minus 8. Minus 4 plus 2 is minus 2. So I can write s square minus 2s minus 8 as s minus 4 s plus 2, right? S minus 4 s plus 2. Super. So we need to apply. So that means our y is L inverse of this, right? So therefore our required y is L inverse of, so required function y of t. So L, see here they haven't mentioned the different variable here, right? So it can be d square by dx square, it can be d square by dt square, anything, right? I'm just taking t, right? So L inverse of 3s divided by s minus 4 s minus 4 s plus 2 s minus 4 s plus 2, right? So we will take this, let us call this as star, right? This is our required answer. So we will find partial fraction for this, we will split up and then we will apply inverse Laplace transform to find the required function. Okay. So we have 3s divided by s minus 4 s plus 2, right? So this is nothing but a by s minus 4 b by s plus 2, right? A by s minus 4 plus b by s minus 2. Now you can see we have two distinct roots, right? So we have two distinct roots. So put s is equal to minus 2. So put s is minus 2. So okay, before that we will multiply throughout by, so we'll multiply throughout by s minus 4 s plus 2. So this implies this will be 3s is equal to a into s plus 2 b into s minus 4, right? I'm multiplying throughout by s minus 4 s plus 2. So s minus 4 s minus will get cancelled, we will have s plus 2. S plus 2 will get cancelled, we will have s minus 4, right? I'm multiplying throughout by s minus 4 s plus 2. Okay. So now you put s is equal to minus 2. So if s is minus 2, we have this will be minus 6. Minus 6, a will be 0. So b will be minus 2 minus 4. So we have minus 6 is equal to minus 6b. So that means the value of b is 1. Now put s is equal to 4. So 3 into 4 is 12. So 12 is equal to a will be 6, right? 4 plus 2 is 6. This will be 0. 4 minus 4 is 0. So we have 2 is equal to a, right? 6 ones are 6 twos are. So we have a to be equal to 2. So we have a to be equal to 2, b to be equal to 1. So therefore our y of t, that is 3s divided by s minus 4 s plus 2 is equal to a by s minus 4 plus b divided by s plus 2. Now what is the value of a? Value of a is we have what is value of a? A is 2. So we have 2 into 1 by s minus 4 and the value of b is 1. So we will have 1 by s plus 2. Now apply inverse Laplace transform on both sides. So we will have L inverse of um, 3s divided by divided by s minus 4 s plus 2. So this will be 2 times L inverse of 1 by s minus 4 plus L inverse of 1 by s plus 2, right? This is e power 4t because L of e power at is 1 by s minus a. So e power 4t and this is e power minus 2t. So therefore this is our required solution. Therefore our y of t is 2 e power 4t plus e power minus 2t. This is a required solution, right? Then what next problem? 2 e power 4t plus e power minus 2t. No doubt, right? This is what the fourth problem. Is there any doubt up to now? Okay. So we'll move on to fourth problem. So this is the last problem we're going to solve today, right? We'll continue fifth problem from next class onwards. Okay, so solve y double dash plus 2y dash plus y is equal to e power minus t. Y of 0 is 1 and y dash of 0 is again 1. 1 or minus 1? Just a minute. Y of 0 is minus 1. Sorry. Y of 0 is minus 1 and the y dash of 0 is 1. Okay. So after Laplace transform on both sides, so we will have L of y double dash plus 2 times L of y dash plus L of y is equal to e power minus L of e power minus t, L of e power minus t, right? L of e power minus t. So L of y double dash s square L of y minus s into y of 0 s into y of 0 minus y dash of 0, right? S square L of y minus s into y of 0 minus y dash of 0. This is a very elementary formula which I have already listed in the beginning of the video, right? Okay. So 2 times L of y dash s into L of y minus y of 0 plus L of y. Now what is L of e power minus t? It is 1 by s plus 1. L of e power minus a t is 1 by s plus a. A is 1 here. So that means 1 by s plus 1. See, L of e power minus t, right? L of e power minus t. So L of e power minus t, a is 1. So 1 by s plus 1, right? Okay. Now we will apply initial condition. So y of 0 is minus 1, y dash of 0 is plus 1. So this will be s square L of y minus s into y of 0 is minus 1, right? Y of 0 is minus 1 minus y dash of 0 is 1. And here we have 2 times s into L of y of 0. So y of 0 is minus 1. And here we have L of y is equal to 1 by s plus 1, right? 1 by s plus 1. Okay. So we will simplify this. So we have s square L of y plus s minus 1 plus s minus 1. And here we have 2 times s into L of y. This will be plus 1, right? So plus 2 plus L of y is equal to 1 by s plus 1, right? So we will be doing many more problems in Laplace transform, right? These looks very elementary, but if I do some tough problems means it will be you need to master Laplace transform to do all the problem. So far we are majority we are using the formula L of e power minus at, that is 1 by s plus a or 1 by s minus a. This L of e power minus at is 1 by s plus a, L of e power at is 1 by s minus a. For these four problems we are only using those two formulas, and L of 1 is 1 by s, right? We haven't touched the formulas L of sin 80, L of cos 80, L of e power 80 sin 80, L of e power 80 cos pt. There are many formulas, but we will go from basic to higher problems, right? So these four problems looks very easy. We will do many more problems that will be quite challenging, right? So don't think that application of Laplace transform ODE we can do that in 2 or 3 minutes. It needs practice. Right? It needs practice. These four problems will give you more confidence, right? Uh, so you take L of I common. So if I take L of I outside, so this will be s square plus 2s plus 1, right? S square plus 2s plus 1, and we will have s plus 1, right? Because minus 1 plus 2 is 1. So we have 1 by s plus 1. Now take these two terms to that side. So we will have minus s minus 1, right? Minus s minus 1. Okay. So what we can do is you can see if I take minus outside here, it will become very easy, I think, right? If we take minus outside here, we will have s plus 1 again. So if I cross multiply this, I think it is very easy. Okay, so we'll do that. So we will have L of y s square plus 2s plus 1, right? S square plus 2s plus 1. And here we have is equal to 1 by s plus 1. So we take minus outside here, it will be minus s plus 1, right? We take minus outside here, it will be s plus 1 again. So if I cross multiply, we will have 1 minus s plus 1 whole square divided by s plus 1, right? Yes or no? So if I cross multiply, we will have 1 by s plus 1, 1, 1 minus s plus 1 whole square. Yes. Okay. Now what we can do is this is nothing but again this is not again s plus 1 whole square, right? So this will be L of actually this is s plus 1 whole square. So we have L of y. This is s plus 1 whole square, right? So s square a plus b whole square formula. So if I bring this to denominator, we will have L of y is equal to 1 minus s plus 1 whole square divided by s plus 1 whole cube, right? Now divide separately, right? You don't need to do partial fraction now again, because you can see all these terms are s plus 1. So if I divide individually, we will have 1 by s plus 1 whole cube minus 1 s plus 1, 1 s plus 1 will get cancelled. So we will have 1 divided by s plus 1, right? So if I divide s plus 1 whole cube separately, 1 by s plus 1 whole cube, s plus 1 whole square by s plus 1 whole cube. So the square and square will get cancelled, so we'll have 1 by s plus 1. Now y is equal to L inverse of 1 by s plus 1 whole cube minus L inverse of 1 by s plus 1. You don't need to do partial fraction. We already know these both the formulas. This is nothing but e power minus t, right? E power minus t is 1 by s plus 1. Now what about this? What is 1 by s plus 1 whole cube? So we know what is L of t power n? L of t power n is n factorial divided by s power n plus 1, right? L of t power n is n factorial divided by s power n plus 1. Very elementary formulas, all those, right? I strongly recommend you to watch my Laplace transform video. I'll attach a link in the description also, right? So L of t power n is n factorial by s power n plus 1. Now you need to make you also you need to know what is meant by shifting property of Laplace transform, right? You need to know what is meant by shifting property of Laplace transform. That is L of e power at t power n, right? L of e power at t power n. L of e power at t power n is, so apply Laplace transform to t power n. Apply Laplace transform to t power n, right? After that, replace s by s minus a. I have already given the proof also in that video, Laplace transform video. This is called shifting property. Whenever you have e power at multiplied with f of t, apply Laplace transform to f of t, right? And then replace s by s minus a. So we can also generalize this, right? We can also generalize this. So whenever you have, just a minute. So whenever you have L of e power at f of t, right? L of e power at f of t, apply Laplace transform to f of t, right? Apply Laplace transform to f of t. After that, in this answer, you replace s by s minus a. And suppose if you have e power minus at means replace s by s plus a. It is L of e power minus 8. I have already discussed all these in Laplace transform video, right? Don't worry. So this is nothing but L of f of t. This is called shifting property. Replace s by s plus a, right? I'm going to make use of this in order to get this formula. Now what is L of t power n? N factorial by s power n plus 1, right? Now you can see you have to compare this and this. S power n plus 1, but we have s plus 1. That means we need to multiply e power minus t. E power minus t, we should have whole cube here. That means n has to be 2. N has to be 2. So therefore, L of, what is L of e power minus t square? Here I'm finding Laplace transform for this. This eventually turns out to be the inverse of this, right? So if we have 1 by s plus 1 whole cube, so it is n factorial by s. It is in this format. N is 2, right? But in the numerator, we should have 2 factorial, but we don't have 2 factorial here. No problem. We'll multiply and divide by 2, right? Now, what is L of e power minus t square? This is nothing but L of t square. L of t square. Replace s by s plus 1. Now, what is L of t square? L of t power n is n factorial divided by s power n plus 1. So, 2 factorial divided by s cube. Replace s by s plus 1. So we have 2 divided by s plus 1 whole cube. So L of e power minus t square is 2 by s plus 1 whole cube. You can see 2 is missing here, right? So what we will do is we'll multiply and divide by 2. So we'll multiply by 2, we will divide by 2, right? Now e power minus t square. So L inverse of 2 by s plus 1 whole cube is e power minus t square. That means this formula, this is nothing but, so we have 1 by 2. So we have 1 by 2. So L inverse of, that is, you just take L to that side. So L inverse of 2 by s plus whole cube is e power minus t square. Very easy, right? See, very simple. Provided you have watched the Laplace transform video. If you haven't watched that video, go back and watch all those videos before tomorrow class, right? Because tomorrow class is also based on Laplace transform only. Okay, this is very easy, right? This e power minus t, L inverse of 1 by s plus a is e power minus t. That's it. This is a required solution. Therefore, required y of t is 1 by 2 e power minus t square minus e power minus t. This is your required answer, right? Okay. E power minus t square by 2 minus e power minus t. Then I got up to now, very easy, right? Very interesting, right? Laplace transform. So that's it. So we'll stop here. The next class we will continue with fifth problem, right? This is the problem we're going to start in next class. So try this problem in your own. It will be slightly tricky, but it is very easy only. In tomorrow class, we will start with this problem. Uh, until just try this problem, right? So in this class, what we have did is we have solved some second order differential equations with the help of Laplace transform. If you haven't joined a Telegram group, so join a Telegram group, Math Press, right? So link is here. I will upload the PDF of this session in our Telegram group, right? The next class, we will continue the fifth problem, right? So thank you, all the best.